Last time we didn't get very far because we were just doing setup. So, uh, you've probably noticed at this point that the setup of the VR character is a lot harder in C++ than Blueprint. If you try to do everything in C++, including the meshes and materials, because in C++ you have to load all of that stuff and parent it and do do this entire structure manually, when C++ wasn't really meant for that. So to kind of mitigate that, we actually, where is it? I actually created a VR pawn last time that has no purpose but to, it doesn't actually have any code, it has no purpose but to help position things, if you were to do it that way. So actually these meshes shouldn't be so big right now. Static mesh, maybe I commented something out. Oh yeah, I did. Whoopsie. Anyway, Blueprint is useful for positioning these things without having to guess their values in C++. So anyway, setup is kind of a pain in C++, but fortunately we don't have to do it again, at least not to this extent. It does eventually become sort of second nature, but it is still a pain, and there are some things that you simply can't do accurately in C++, like figure out the exact values that you need to move things, like the Raygun, so that they look right. So that's a lesson learned. I'm just going to restart this because Blueprint apparently is not reloading with these relative locations. Anyway, so today we're going to do the shooting. Something to note, last time I was having a lot of autocomplete problems. I found that... Okay, Blueprint, thanks for nothing. Actually, I'm gonna just stick with the C++ class. Blueprint is not actually updating with those new values. So I'm gonna use the CPP version instead. Okay, last time I was having problems with autocomplete, and I found that even though things like these static mesh components and the materials, like here, the static meshes and materials, they do compile without needing to import them specifically. I'm guessing that there's some definition of them in core minimal. If you want their functions to autocomplete, you need to actually import the specific relevant includes. So for material, you have materials.h. For meshes, you have this. And after that, I don't get the squiggly lines anymore, and it should also now autocomplete things correctly. So just something to keep in mind, because autocomplete is really useful in general, but it's especially useful in C++ where the syntax can be kind of awful. Let's see, what else? Last time I mentioned that when I imported the Raygun, it was already defined as being gold. I didn't actually mention where I did that. You can do that in the static mesh itself. So in the static mesh, you can set its default material, and in the project that I imported this from, it already was assigned to use this material, and so it already knew the path to load it from starter content. So when I dragged this Raygun into this project, it just worked because it knew where to find the starter content. If I didn't have the starter content already in the project, it would have not done that. It would have loaded as gray. You may have seen before that, like, traditionally when textures or materials are missing, they turn pink, like hammer editor, missing texture. Hammer editor was it's by Valve. It's what you use to make source engine maps, and like this is kind of the standard for missing things, but Unreal just kind of nullifies them and uses a default value. What else? I also mentioned last time that the reason that it knew to make this the root is because the reason that it knew to make the tracking center the root is because that was simply the first thing that I initialized, which is fine, You can also explicitly tell it which root to use if you want. It's, I believe, let me see if I remember this off the top of my head. I think it's this root components. Yeah, and then you could say equals something else. So, you know, you could say VR tracking center if you want to explicitly say what the root is. Any last notes from last time? I'm aware that not everybody who watches this will have a VR headset, so you can set up a first-person character. Well, this project was already a first-person template, but we can set up some of the first-person code ourselves just for the sake of being able to WASD and look around. The way that we'll do that is in the first-person templates, they already defined these axes for us to use. So move forward is W and S. This is an axis because it's on a scale. So, for example, on a joystick, it would interpolate from 0 to, or it would interpolate from -1 to +1. With key inputs, they make it so that when you're not pressing anything, it's equal to 0. When you're holding W, it's 1, and when you're holding S, it's -1. And you also have move right, which does the same thing. And they also have rotational axes. So turn is mouse X, so left and right. Look up is mouse Y, up and down. And we can use these to make some very simple input code, just for the sake of being able to test this without a VR headset. So this function, setup player input component, I think this is actually new to, or it's relatively new in Unreal. I remember years ago this actually didn't exist, but now they have this callback function, which you can use to bind axes. So it lets you, it basically gives you a dedicated place to do what this is doing, basically. I don't know why it keeps opening these on a different window. It gives you a dedicated place to create these kind of callback functions. So to do that, they have something called bind action, which we'll see later is for actual button input, not joysticks. And then there's also bind axis, which is for those axes that we saw. So just to kind of, I'm just going to copy my code so I don't have to write it again, but you do it this way. So, or we have to do some more work after this, but you have these functions, bind axes. You have bind axis, which requests a name. The name will just be whatever its name is here in project settings input, and which object to bind it to. In this case, we're just binding it to ourselves because we want the callback to be called when we are receiving the input. And then it asks you for a function to which to bind this axis, like which function it will call when the user is actually doing something that will cause this to not be 0, I think. I think it calls it if it's 0 anyway, but I could be wrong about that. But anyway, we need to define these functions, which is simple enough. We can do it here in the header. So I happen to have created these already. The callback functions in C++ are kind of weird. They have some implied parameters. So bind axis, you can sort of get an intuition for this by looking at the blueprint. So with bind axis, I actually don't know that I was using an axis in the C++ project. Move forward. I'm sorry, blueprint. I don't know that the blueprint project had any axes. Let me see. Inputs, oh yeah, it did. So motion control, or forward, okay, so forward. It had an axis forward, and its parameter was a float called axis value. So the callback function in Unreal, or sorry, in C++, will expect that you're binding it to a function that has this a parameter that is a float of some name. And it's hard to tell from just looking at the bind axis line of code, but it's something that the compiler will complain about later. So actually I can show you what will happen if you don't do this. So let's say that I just want to create the move forward function for now, just for the sake of doing something. and I don't actually give it a float axis value. And I want it to bind to this move forward function, and so I'll do, this is void move forward, I'll do void move forward. Remember that the header declares the, it's like C, so the header declares the function, but the body actually has the code that the function runs. So move forward. Let's say for now it doesn't do anything. When I try to compile, I believe it will complain that I don't have the right parameters that it's expecting for this axis input. Let's see. It might not complain simply because, like it's, okay, never mind, it will. I was gonna say maybe it won't complain and it just won't return anything. But you can see that it's unhappy, and C++ throws really ugly looking errors, and you may not be able to tell what the error is just from looking at, or what the error means just by looking at it. That's just kind of a challenge with C++. But I happen to know that it's complaining that I don't have the float that receives the value of this axis, which is this. I don't have a float that tells me how much are they pushing that joystick. So I can do that. I'll add back float axis value, and I'll put it back here, and now it should stop complaining. That's actually not the weird, that's not one of the weirder C++ errors that you'll see. We'll see much uglier looking ones that don't make any sense at all, really. But in any case, I don't know why this is taking so long to compile. But it did compile this time because now it has this axis value that it was expecting. So with this axis value, we can move the character. So just like in Blueprint, you have set actor location, get actor location, and you also have add local offset, which is for like just adding some amount of location. We can do that in C++ as well. So for move forward, we can do this add actor local offset, which is for adding locations, and we want to use, for moving forward, we want to use the get actor forward vector. This should actually be world offsets, because the forward vector is in world coordinates. That's a subtlety that won't really become intuitive until you work more with Unreal, but you should keep coordinate systems the same. So forward vector is in world space, so you should be using it for world calculations. Anyway, what I'm doing here is I'm saying to my current location, add the forward vector, which is a unit vector of length 1 centimeter, and multiply it by whatever the axis value is. So this will be very slow right now because 1 centimeter per frame is very slow, but you'll see that it should work. Well, actually, it probably won't for a reason that I'll mention in a second. But I'll just compile and test it out. The reason that this won't work is, if you recall, something that probably tripped you up in the 590 assignments was that if you don't tell it to receive input, it won't. So you may recall this annoying problem, auto receive input, is if it's disabled, then none of these callback functions actually run. And so you had to enable it. Or actually, maybe we didn't have to enable it because, maybe in this case we don't have to enable it because it's the only pawn in the scene. But generally speaking, if you throw a pawn into the scene and then possess it, and it's not a pawn that is a part of the game mode, it won't receive any input. Anyway, again, it's a subtlety that you may or may not run into. But let's see if it works. Okay, yeah, so it's not working. So we need to force it to receive input, otherwise it just won't. Oh, actually, I don't know that it even compiled. This might be one of those situations where I mentioned last time that the compile button and the Visual Studio compile don't always match up, and sometimes the editor won't actually update your code until you hit this compile button. Let's see if that's the case. I didn't notice before whether or not it had the hot reload at the bottom. So I actually don't know if the C++ updated. But when you compile from Visual Studio, you'll know whether or not it updated in the editor because it should make that noise that you just heard. You won't hear it through Discord, but it'll make this little robot noise. Okay, yeah, so the Visual Studio compiling is just not updating in the editor. Great. That's annoying. It is moving forward though, so that's good. I guess this is the only pawn in the scene, so there's no ambiguity about which input it should receive. But if you do run into that problem where it's just not receiving the input, like you're hitting a button and it's not doing anything, there is a C++ equivalent to changing this to be player 0. The C++ equivalent is in the constructor. The constructor is used for initializing everything. You just do this. So an actor has a predefined, or pawn I believe has a predefined, I don't remember if this is actor or pawn. It seems like it's pawn. But it has a predefined variable called autoPossessPlayer. And actually maybe I should. You can't hear me at all? Can you hear me now? You can't hear me? Discord seems to be... Maybe your mic is messed up. Or I mean your speakers. So you still can't hear me right now? Okay, cool. Anyway, autoPossessPlayer is a built-in, it's an inherited variable from pawn. You'll notice if you hover over it that it is of type eAutoReceiveInput, this enum. So you may not know what values are possible for this enum right now, but you can type it in, eAutoReceiveInput, and use 2 colons for things that are static like enums. And you'll see the options that are possible here. So in this case, I want player 0. And this will, I'm actually not going to build it because it was working already, but you can use this to do the C++ equivalent of forcing it to auto-receive input from a certain player. And yeah, like I mentioned, anything that's static, like static classes or enums, instead of using dot or the arrow notation, you use this double colon notation in C++. And I think that's how you do it in C as well, but I don't remember C well enough. Let's see. Anyway, so just to move on from this, because having a first-person character is not the point of a VR lecture. You want to do this for all of the axes. So move right is going to be basically the same as move forward, except you want to use the right vector instead. So let me find this quickly. Get actor, right vector. Forward, right, and up are always in world coordinates, but we'll actually notice a problem with using world offset in a second. Actually, no, world offset will be fine. Never mind, sorry. Yeah, this is in world. This should also be world. Rotation is what will be a different challenge. So let me declare this. Move right. It has the same float parameter. The turning is where it becomes more complicated. So with turn, I want to use add actor local rotation. For moving forward, or sorry, this should be turn. I renamed the wrong one. This should be turn, and I want add actor world rotation. It expects a rotator. If you recall, a rotator is kind of just a 3D vector, but it has pitch, yaw, roll instead. So autocomplete is really not making my life easy right now. The first, it's in that order, pitch, yaw, roll. So when you want them to turn left and right, you use yaw. So 0, 0, or it's pitch, yaw. Yaw is the middle one, roll. I need to declare turn. And I also need turn up. It's a terrible name for a function, but whatever. And turn up is actually where we'll see that world rotation is actually not a good indicator for rotations. But for now, let's say F rotator. When you want them to turn up and down, you should use pitch. So we want the first axis to be axis value, and this to be 0. So it's increasing your amount of pitch right now. If we compile this, actually I don't know why I compiled it from VS, because obviously it's not updating in the editor. I should just hit the button in the editor from now on. Move forward already has a body. Oh, I accidentally named this wrong. Anyway, I'm going to compile from here because before it wasn't actually updating in the editor. And the movement will work, and turning up and down will work, but you'll notice that turning left and right is going to be janky. Or actually turning left and right will be okay, but turning up will be wrong. So anyway, moving forward and back works. It's very slow. You can multiply axis value by some constant to make it faster. But what you will notice is that up and down seems to be okay, but when I start turning like this, notice how the rotation's not really doing what I want to do. And that's because for rotating them left and right, I want them to rotate along the z-axis of the world. So I want them to rotate around the axis that's straight up. But right now what it's doing is it's rotating them along, or sorry, yeah, so for left and right I want them to rotate around the global z-axis because I want them to turn left and right in world space. But for turning up and down, I don't want to use world space because I don't know that the global x or y axis is actually the axis that describes like my camera. So maybe it'll make more sense if I throw a camera in the scene. Okay, so if I have a camera and I want to turn left and right, I always want to turn left and right globally, like this. So even if I'm facing upwards like this, not too upwards, even if I'm facing upwards like, this, I want to turn around global z-axis, not local, because if I use local axes like this is the local z-axis. If I do this, it's also changing my pitch. It's like if you were to turn your head sideways, which can be sickening in a first-person character. I don't want it to do that. I want it to always use global, which is what I'm doing now. But then you have the other problem of up and down. So when I turn up and down, if I'm using world coordinates, you can see that I don't have really, I want it to rotate along this vector, like I want it to rotate around which way is actually left and right for my head, so that it rotates like this. If I use a global axis for this calculation, it's not going to be right. You can see how it's distorted. So for up and down, I want to use local axes. That's the moral of the story. So turn up should be add local rotation. And you'll see that it will not screw things up as badly. And I don't know why I keep compiling from VS, because that's obviously not working. Let me delete this. I guess it didn't actually stop building. Huh. Weird, I told VS to stop building, but I don't think it actually did. Good old Visual Studio. Okay, no, it's okay. I didn't actually expect to spend so much time on the first-person character controls, but since not everybody has a VR headset but might still want to write VR code, I think it's worth going over at least. Alright, so this compiled, so you can see the hot reload message, which wasn't showing up through the Visual Studio. So you can see I can move forward and left and right, and the left up and down motion is not causing that distortion, like it's not going this way. But right now my mouse input's actually flipped, so when I push up on the mouse, it moves downwards. So up and down should be a negative axis value. And you can see that move forward and move right is really slow, so you can also throw in some floats here. So floats, translational speed, let's say I want them to move 2 times as fast. Floats, rotational speed. This I think was okay already, so I'm going to leave it at 1.0f. Multiply this by translational speed, and rotational, we multiply by rotational speed. Whoops. Okay, so this should be the end of dealing with this first-person character. I just wanted to make sure you had a way of simulating this. And you'll notice in the first-person character, your gun is still pointing forward, because even though it doesn't know where your motion controllers are, it initialized them so that they're pointing forward. So you can actually still do things like click to shoot the gun, and that will still work. So you can see the gun is right here. I can't see my camera, but it's fine. You can see the gun is pointing forward. Yesterday wasn't my birthday. Move forward is slightly faster. Rotation is now in the right direction, and all of it works. And you can change translational speed to be whatever you want to suit your speed needs. But that's just for simulating the character, and I don't want to spend too much time on that. But here's your basic first-person code. This is actually pretty simple, and you can add a U property to translational and rotational speed so that you can change them in the editor. So let's say the categories will be speeds, and edit anywhere in blueprint read write is still okay. And if I add this U property, what it means is that I can eject from my character and change the speeds, or if I throw a character into the scene instead of spawning one, I can change that initial character's transformation or speeds, or I could do it in blueprint. If you don't have U properties, then there just is no way to edit these values from the editor. So if I play this character, you can see right mesh, pawns, what in the hell? For speeds. Get out of the way. Speeds for translational. Didn't update. Why is it not updating? You will run into this problem a lot with C++ where things just don't update at the right time. It is kind of annoying, but that's just kind of the name of the game. It's why I would say the blueprint's a better option for things that you're going to, for small pieces of code that you're going to edit a lot, blueprint's actually the better option. C++ is more for things that are computationally expensive that you don't have to edit that often. Why is VS being so slow today? This didn't hot reload, but I'm hoping that forcing it to recompile that way will update this now. Oh, there it is. Okay, speeds is there. So now you have translational and rotational speed, and you can edit them. So, yeah, there it is now. So translational speed, if I make it 10, it'll be really, really fast. And I can WASD, and my rotation is not horribly distorted like last time. So there you go, there's your basic WASD and rotation code. Just to clarify, the reason that usually if it's not updating the project, like it just wasn't at that point, that indicates that it's not actually clearing the binary that's in here. So it has all these binaries that it's compiling every time you compile. It's supposed to be cleaning these out every time it recompiles, but sometimes it doesn't, like maybe an asset is being held for some reason. And doing it in Visual Studio, I think that Visual Studio tends to be better at the actual cleaning process than the editor is. So sometimes forcing it to recompile in Visual Studio and then compiling it in the editor will, like, I don't know, kind of force it to unlock things. I'm not really sure. I don't know all the internal workings of how Unreal C++ modules work. But anyway, let's move on to the actual VR stuff. So now we want to shoot. So to shoot, we need to make an input that actually shoots. They had this fire input, which I guess is good enough. I actually wanted it to be the left trigger in my simulation. I'm gonna remove their code, or their inputs. I'll just make my own. I'm not left-handed, I just happened to, in the class demo, use the left hand for the left gun. So, shoot gun will be Vive left trigger. And for, if you're working on a desktop, you can also add other inputs like mouse left, if you want to simulate VR without being in a VR headset, and it should still work. So here we're setting up the input name. Now, similar to how we bound the axis here, we can also bind these single events like shoot gun. So we have bind axis, but we also have bind action. Just look here. So you have bind action, and here's an example of where the C++ headers are just like so unreadable. I actually find that the online API reference is a little bit better at this. So if you look up, for example, UE4 C++ bind action, their online reference is a little bit better, I think. Or it's a little bit more readable than what Visual Studio shows you. My internet's being really slow for some reason. So here you can see a little bit clearer. What they want is the name of the action. They want a key event, and you can see different types of key events. They really just mean, like, the ones that are most useful to us are pressed and released, but you have some other options, like double click is pretty cool. And then you have other things. And the object is like what you're binding the action to. If you recall, that'll just be this. And then it's binding it to a function. And it's ugly. Looking at it this way is ugly, but they really just mean they want a function. See? The way that it's defined here is just really ugly. So, anyway, we need these things. So, I want to bind an action to shoot gun. I want it to be IE, the second one was called E inputs event. So E input event, we have some options. I want to do pressed, so I only want it to happen when they press the button, not when they're holding it down or releasing it. I'm calling it on myself, and then you need to again bind this to a function that has the right signature. With actions, you actually don't need the access value because it's fine for it to just call a function one time. So I can just make something called like shoot gun pressed. And I need to define this in the header. This is getting ugly, but let's do shoot gun pressed. And for now, let's see. For now, I just wanted to say on my monitor, I wanted to say on my face, in the text that's supposed to be in front of my face, that it actually shot. Right now, I actually haven't defined the location of the text the way that I did with the guns, but we can do that quickly. I had some code for this. So there are a couple of things that you can do to initialize the text. So some things that I did personally were I loaded a material that's unlit text. So text, the default text that Unreal uses is actually lit, which means that if you go into the shade, you can't really see it because right now it's not in the right place, but if you go into the shade, it's actually affected by shadows, which I think looks bad. And it also means that it can be hard to see the text sometimes. Like if I go into the shadow here, the text is going to turn very dark. It didn't turn that dark, I guess. Maybe it's because I'm... Oh god, I didn't mean to do that. Anyway, I want it to be unlit, so I want it to not be affected by shadows at all. So I loaded this material that's a translucent text material. You can find this material by if you just throw a text into the scene, you'll see that it has this material by default, the opaque material that's also lit. If you look in the same engine content directories, you'll see that there's also a text translucent material, and this is unlit. So I'm just using that. So like before, you can copy reference and just get its path, which is what I did here. And then I set its material, and then I set it to be red. And some other things that we can do are set where it's actually located. So I'm going to add these properties. So there are properties like its alignment, and in C++ you can center everything by doing it this way. You can just do output text and its alignments, and it has these enums for alignments that you can use. And I'm also setting its relative rotation and location. The rotation I'm changing because if you noticed, it wasn't actually facing me, the text. See, the text is actually backwards, so I just set its relative rotation to be backwards. And its location I set to a position that happens to work, so I set it to be 150, which is far enough that I can see it. So I already saved it. I'm going to compile it quickly. Well, actually, I'm going to wait to compile it. I want to set its text so that when I shoot the gun, it sets that text. So I'm going to say this, output text, shoot gun. And I will test it in both VR and on the desktop for now, just to show you that both of those work. Also, I'm going to change my output device to be the headset. Actually, no, it'll be fine. What is it complaining about? Bind action requires something. Oh, I didn't bind it to the right one. Shoot gun pressed. It's complaining because I'm trying to bind it to a function that receives a float, but actions don't actually send a float. So you'll get these ugly errors when there's a mismatch with callbacks. Callbacks in C++ just look really ugly, and it's unfortunate, but that's how it is. Also, you might get this error, or you might get this warning occasionally that they want you to use a text, but you're using a string because I'm just giving it a string like this. Ftext, this whole ftext, fstring thing is annoying. There's actually a good online article about it. UE4 sending messages to yourself. I think it's UE4 C++ ftext fstring. There's an article that I'm looking for specifically. I don't know where it is. UE4 C++ output log. I don't remember the name of this article. I think it's by this guy. Oh, here it is. Yeah, it's this article called this. You can look it up, but it's a nice Unreal topic. It's a nice Unreal article that tells you how to convert between these types of strings. Ftext is for like if you have specific formatting conventions like $signs or things like that. Fstring is basically just a string. So C++ has actual strings, unlike C. And then there's like fname, which is, I don't know, it's like a string that's for the names of things specifically. I actually don't know why they split it up that way. It seems like they could have just used one class, but whatever. If you want to suppress this warning so that you don't see it all the time, because it really is just a warning, at the very top of this file you can throw in pragma warning disable. So this is a C++ macro that will tell it to stop doing that. And I'll compile it quickly. And show you that it works. I'll also turn my controllers on. You can see that even though this computer has a really strong CPU, well, first of all, Epic Games Launcher is always using a lot of CPU for no reason. Anyway, the compile process uses a ton of CPU, so be careful, I guess. Anyway, I shot. See, it shot it. And if I do it in VR, if I do it in VR, I actually don't know which one the left controller is. I should be able to see it. Okay, yeah, here's my gun. If I hit the left trigger, it says shoot gun. So there we go. We have our callback functions. So we did the C++ equivalent of this. And you can also bind a release. In my original Blueprint lectures, the only reason I was using release was to say that I released it. So you can do that if you want. I'm not really going to bother for now. So we have the input bound. Let's move on to actually doing things. I added 3D text. And now I need to shoot a bullet. And so my goal for these workshops is to do absolutely everything in C++. So the bullet we're going to do in C++ as well. So I'm going to add a new C++ class for a bullet, which will just be an actor, I guess. I think an actor is fine. It could have just as easily been a static mesh actor, but just say we have a bullet, and I'm going to create it. And we're going to, I'm not going to bother with much of the setup of the bullet just yet, apart from initialize its mesh. So remember, we have to set all this stuff up ourselves because the bullet doesn't, I mean, C++ doesn't do anything for you. So we're going to have to do a couple of things ourselves. I want the bullet to have a mesh. If you recall from the C++ lectures, the bullet was just this little baby carrot thing. In this case, I had a scene root and a sphere. It doesn't need to be a scene root. I can just make the sphere the root instead. So I'm also going to call it something better. I'm going to not worry about access conventions right now. I'm going to make its mesh. So I'm just going to do our old-fashioned... well, I need to include things. I need to include the constructor helper so that I can load its meshes. I need the material and mesh. So I declared bullet mesh, and now I want to... For now, before we worry about the physics or anything, I'm just going to initialize these things. So I need to remember that you can't tell just from the header whether or not this is a pointer to something else's component or your own. We need to use this function in the constructor to initialize it. Create default subobject. I am going to force the bullet mesh to be the root component, although I think it will already just because it's the initial. It's the only thing that I actually initialized. I'm also going to load its material. So I want it to be red, so I'm going to make a red material for it. Materials you do need to make in... materials don't really make sense to do in C++, in my opinion. I don't think there's ever a good reason to do this whole thing in C++. I mean, if you were going to do that, you might as well just use GLSL or some shader language. So I have red, which I want to use for my bullet. Looks more orange, but it's fine. I'm going to load it, so it's in the root of the directory, so it's just game/red. And I'm going to call it loaded red. And I'm going to set its material to be this. So here we have our basic bullets. I don't have any bullets in the scene. Let me compile it. And if your mesh initialization stuff works out, it should, the icon should turn into this. It should turn into like an actual thing. Oh, it didn't because I didn't actually load its mesh. I need to load to be a sphere. I'm also going to get rid of player start. And shrink these. This is a pain to look at. I need to tell them to use a sphere. And I also had a sphere of a specific scale, so I made their scale this so that it's an ellipsoid. So I'm going to do that in C++ and just copy my code that did this. So it's the same as before. You're loading the object. You can figure out where the sphere is by just throwing a sphere into your scene and looking at it. So if I throw a sphere, I can see that it's here. I am setting it to be that, and I'm setting its scale. So now it should turn into that icon. Yay, now we have a bullet. So there we go. There's our bullet. And I'm going to spawn these things when I shoot my gun. So I need to, in order to know what a bullet is, I need to include it. So include bullet.h. And now, in my shoot gun function, I want to create these things. So it looks like I'm going to throw in the shoot gun released just for the sake of having it print out when I release it. You can write iRelease like this. It doesn't matter that much. Shoots gun released. Shoots gun released. Where did I declare this? Shoot gun released. And all that this function does is print out that I released it. It's just because you can't see what I'm pressing, so it's useful. By the way, if you want to call these functions in blueprints, Just like you have U properties and you have U classes, you also have U functions. So I can say U function, it has a parameter called blueprint callable, which lets you call it in blueprint. So if you did want to write blueprint code that calls a C++ function, you would just add this. Anyway, so when I press the button, I want it to spawn things. So I need to know where to spawn it and which direction to spawn it. So if you remember, in Blueprint you have this function spawn actor. In C++ you also have this function. So and I also need a reference to the bullet because I'll eventually need to add physics to it, and you can see that spawn actor returns the object that it spawned. So, oh gosh, something caused it to suddenly use a ton of CPU. What in the world is happening? Close this. Anyway, moving on. You can do this by, I have a bullet, so I have A bullets here. I want spawn actor to return this, so new bullets equals, to spawn things, actors have this built-in function get world, where you can get the actual world that they're located in right now, as in that level. And oh my god, why is it not auto-completing right now? It's such a pain. Build. Sometimes building fixes this. Sometimes including engine.h helps with this autocomplete stuff. Because engine.h, and also making this not core minimal but core, sometimes this makes it include more information that it can use to actually autocomplete correctly. Let's see. This is not green, which is annoying. This computer is acting very slow today. Alright, it didn't make the noise in Unreal, which means it didn't compile here either. But I'm hoping that it just... No, it's... I give up. Anyway, I had that code from before, and I have get worlds. Maybe if I do this... No, it's just not auto-completing at all. Great. This get world. The function is spawn actor, and spawn actor needs a couple of... Oh, I forgot this. Spawn actor needs a couple of parameters. Yep, I think it just... Visual Studio just gave up on trying to autocomplete stuff. It needs the class of the thing that you're spawning, and you can do that by doing this. Remember that in Blueprint you differentiate between objects and classes. So classes in Blueprint are purple, and kind of like in Java how you have the getClass function. Hey look, Visual Studio finally decided to update. In C++ you have static class, which will give you a class reference to this thing instead of a specific object. And this function also needs location and rotation. And I don't know why exactly, but they need to be constants, which is a bit of a pain. That means that you need to declare them as local variables. So I need a constant vector for the location, and I want it to spawn at the tip of the gun. And remember that I specifically positioned the left cone so that it is at the tip of the gun. So I'm going to use its location. Get actor location. Oh, left cone is a component, it's not an actor. I'm not sure why exactly, but in Blueprint you have get world location for components, but in C++ it's actually get component location. So it's just a name change. I need to do the same with the rotation, constant F rotator. Also, I'll end this right after we actually get this thing to shoot correctly. I need the rotator to be, I want it to be, let's see, I think that I don't remember the process that I used in class, but I believe that I naively just made its location be whatever the left cone's rotation was, which if from class this is actually wrong. But let's just say, for example, that we use get component rotation. And to feed these to this function, you need to dereference it, or you need to get its actual value, or pointerfy it. I don't remember what exactly this does, by name at least. You need to pass it in like this. So you need to give it the actual data from these, and it can't be a pointer because it gets upset, so you need to make local variables. This is one of those things that you probably would not know that you need to do, except by struggling with this a lot. But in any case, it spawned it, so let's compile quickly and test it out. These things that, let's complain about, cannot convert from A actor to A bullet because I didn't cast it. Let me just throw the cast in there. These things that are not intuitive at all, these kinds of problems that are not intuitive, like the constant thing, you would learn them from just practicing and failing over and over again, but hopefully if you run into these, you can look back on this video and this will be a reference for how you're supposed to fix this. I don't know why I compiled it in Visual Studio. Oh man. Oh, also, spawn actor in Blueprint requests a spawn transform, and these things are actually all defaults, so you don't have to actually feed them in C++. But spawn actor has a couple of overrides. It has a couple of overloads that you can use. Some of them will request a transform. I'm using the specific overload that just asks you for location and rotation because I don't want its scale to change. Remember that I just want to use its normal scale. Alright, so compiled. Let's look at it and test it out. It's upside down. I don't know why I'm all the way up here. So if I shoot, it spawns the cone, or the little baby carrot bullets. Their scale is actually wrong. Is it? I don't remember if they're supposed to be smaller than this. I think I intentionally made them big. But you could always force them to be a certain scale if you want them to be. Anyway, you'll notice that they're not facing the right way. The reason being that I want them to face in the direction of the cone, the pointy part of the cone, but the pointy part of the cone is actually the up vector, not the forward vector of the cone. And they're not doing anything, so we need to add the physics ourselves. So to do that, first of all, let me check the bullet to make sure I changed the scale. I did set its scale. I think that it's just gigantic, the sphere. I can make it a little smaller. Actually, I want to make it bigger because you won't be able to see if it's too small. Anyway, we need to add the physics ourselves, and we also need to make it do things. So, first things first, we need to make it do things as in have physics and shoot. Let's worry about physics first. To add physics, I need to tell the bullets, all I need to do is the equivalent of simulate physics in C++. And I also made it have a certain amount of mass. To do that, you do that in the bullet constructor, as usual. And there is a function for this, and it is the same as in Blueprint. if you call it as a function. It's just set simulate physics. And we needed to do other things. The collision presets, I believe, will get redefined automatically, but we also need to tell it to... Actually, let's worry about one thing at once. Because we don't need to worry about event hit until we want it to color the cubes. So let me compile and play this, and if you remember from class, we had this problem where, yes, I can shoot things now, but they roll off the gun because the cone and the gun have physics themselves, or they have colliders, and I didn't tell them to be overlapping yet. So I need to fix this. And to do that, I can do it in the VRPawns constructor. I just tell them to be overlap. So there are these functions. I'm just going to copy them because I'm already over time. First of all, there are these functions that you can use to force it to tell it to have collision or not have collision. For the left cone and the right mesh, you probably could have just used physics, like physics only. I'm using query and physics simply because I want to. I mean, physics only is fine. This is also fine. So this will set the actual collision enabling. So the where is this? Like here. So set collision enabled query and physics. It's just saying whether or not it can collide with things. Now I need to tell it that the cone and the right mesh should overlap but not actually collide. And to do that, there are these functions: set collision response, and you can see it uses this enum collision response, and it has some options like ignore, where it just won't respond at all. Block is for if you want it to be, if you want it to be blocking, like what it's doing right now where it's stopping the bullet from moving. Overlap is what we want because later on we're going to be grabbing things. So we want it to initially overlap events but not hit events. So this will solve the cones, and the Raygun I also set to have no collision, so I don't need to worry about its response. This will solve the problem of the bullets rolling off the gun, but it won't actually add any impulse. Also, when I removed player start, it stopped me from spawning in the right place. So let me put this here. So, testing this up quickly. See so it's not rolling off the gun anymore, it's just falling straight down. I need to add impulse to the bullet when it shoots out of the gun so that it actually does something. Unfortunately, I have a bullet reference that Spawn Actor gave me, so with that I can actually do this. I can tell it to have impulse. So it is fairly simple. One nuance that you should keep note of is that in Blueprint, when we called add impulse, we actually called it on the static mesh of the bullet, not actually the bullet itself. And the same is true in C++. So we want to do new bullets dots, or bullet mesh, which is the mesh itself, and then it has add impulse. And it has a lot of add impulse functions. I actually think that C++ has more physics functions than Blueprint does, but I could be wrong about that. I think that's true though. That may not be. So add impulse's parameter is one of its overloads asks you for just the vector of which way it's going to shoot. And remember that I want it to shoot in the direction of the pointy cone, which Oh, actually, no, let's do this first, that's fine. I want to shoot in the direction of the pointy part of the cone, which is the up vector. So I want get components, or no, I think it was just get up vector. Yeah, there it is. And there are going to be a couple of things wrong that we'll see. Well, there will be two things that are going to be wrong. The bullet will not be facing the right way, and this amount of impulse is not enough to really do anything. Because 1 centimeter of impulse per frame is not really much. So you could see that it's first of all not spawning in the right direction, and the impulse is really not enough. So I don't remember what the bullet's masses were by default, but for us to be able to shoot objects, like, let me set up the table quickly. Let me set up a table. Like this, just to have a couple of cubes for us to shoot at. The cubes will just be like 0.2, 0.2, 0.2, I think is good. They are simulating physics and their mass is like 5 kilograms, which is fine. I'm just creating some cubes for us to shoot at. When we do add impulse, you'll notice, let me do one thing at a time actually. The point is that the bullets are not going to be heavy enough to actually knock the cubes over. So to make them shoot faster, I need to add some amount of juice to the impulse. And also, they're not facing the right way. If you remember in Blueprint, we used this function, make rotation from X, which it basically gives us the rotation that the bullet needs to look in the direction of the pointy part, the up vector of the cone. And in C++, we can do the same thing. So instead of using the cone's component rotation, we can use make rotator from X. Make rotation from X is inside of this thing called Kismet math library, which I might need to import. Kismet math library. Yes, here it is. So we want to use the math library. Kismet is the name of two things in Unreal 3 and 4. Well, actually, in Unreal 3, Kismet was the name of their math library, but it was also the name of their like old jank version of blueprints. Nowadays, it's just the name of the math library. So, Kismet's math library. Thanks Visual Studio for not auto-completing anything. And it has make rotator. This is a static library, so it has make rotator from X. And we are once again using the up vector, like in Blueprint. God, this is so annoying. The auto-completion being bad is just so irritating. So this should solve those two problems. The bullet should face the right way and it should shoot decently fast. I think that after the very next part, I'll end this. And next time we'll do teleportation and stuff. So let me test this out. So when I shoot, they are facing the right way. And I didn't give it enough juice, but they are shooting the right way. Well, they're shooting forwards, which means that the impulse is now high enough that they actually do something. And they shoot in the right direction. So that's good. They don't have enough juice. And I can handle that by just adding a couple more zeros. Oh my god, I didn't mean to close Visual Studio. It's fine. Can't see my mouse. There it is. Alright. Thank you, Visual Studio, for getting in the way. Get out of the way. Okay. So, pew, 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 pew. You can see they're shooting very quickly. My space is not oriented the right way. But, well, actually, right now they're shooting so fast that I think that they're shooting so fast that they're breaking the physics engine a little bit. So let me remove a little bit of juice. While this is compiling, the reason that we use make rotator from X specifically is because X is, the local X axis is the forward vector. And so make rotator from X, because when we orient something, we usually orient it with respect to the forward vector, because that's which way something is looking. Make rotator from X gives us the calculation that we need for something to face something else. There are other make rotators, but make rotator from X is the best for facing things. So, back to business. My bullets, I guess they're okay. I don't know why the physics is so jank. I think the update frequency is just not high enough. These bullets are kind of weak right now. Let me see if I can quickly get the physics to be better. Optimization. Physics up delta time. I want it to update at 30 frames per second. Oh, that was 30. 60? Yeah, I'll leave it at 60, fine. Anyway, the bullets were very, they're kind of light. We can set their mass inside of the bullet's constructor, kind of the same way that we did it in C++, or I mean in Blueprint, where you set the mesh's mass scale to be a certain value, and you can also set its actual value in kilograms. From my testing, I happen to know a value that was good for these bullets. And also remember that there's a relationship between gravity and mass. And so if I make the bullets much heavier, they're not going to shoot out as fast, which we'll see is a problem in a second. But I'm going to make them 1,000 kilograms just so that they definitely knock over the cubes. And when I test this, you'll notice that, well, they shoot out at a pretty reasonable speed. Why is that? Did it not update? I think it updated. Anyway, let's add some more juice so that they can shoot out better. I think that should be okay. This is going to be I'll end here once I test this. I thought we would get far enough to be able to teleport, but doing things in C++ and explaining things takes so long. So it's kind of fast. I don't know, add a couple zeros. When I was testing this before, I was using this value. Which ended up being pretty good. So hopefully this is good now. Otherwise, for next time I'll add a table of more cubes. By the way, to do this easy copying where you can just select things and then duplicate it without copying and pasting, you hold Alt while moving one of the directions. Pew, pew, pew. That seems to not be enough. Well, they're definitely heavy because they're moving that gigantic block. Or also, actually, I think that the giant blocks had their mass hard-coded. Whatever, you can add any amount of impulse that you want that'll make it shoot fast enough that it'll make a difference. I'm going to end here and upload the video. And next time we'll do teleportation, which shouldn't take that long. Definitely not as long as this. And then we can do grabbing. So yeah, I'm going to log off now. Bye.